Welcome to this comprehensive guide on Zenject, also known as Zenject, a powerful dependency injection framework for Unity. This video will walk you through the basics of dependency injection, Zenject's core features, setup, and practical examples. Dependency injection, or DI, is a design pattern where a class receives its dependencies from an external source, rather than creating them itself. This promotes loose coupling, making your code more modular, testable, and easier to refactor. Zenject automates this process, providing a DI container that manages the creation and provision of these dependencies. It encourages adherence to the single responsibility principle, allowing classes to focus solely on their core tasks. Benefits include improved refactorability, modularity, and testability, leading to more robust applications. A common misconception is over-reliance on interfaces. Create them only when a class has multiple implementations or is expected to in the future. Now, let's get Zenject set up in your Unity project. The most common and beginner-friendly method is to download the zenject.v.x.v.x Unity package from the GitHub releases page. Alternatively, you can install it from the Unity Asset Store, though it might be slightly out of date. After installation, a Zenject project typically starts with a scene context mono-behavior in each scene. The scene context acts as the entry point for Zenject to set up scene-specific dependencies. For global, project-wide bindings that persist across all scenes, you can create a project context. The project context ensures that global dependencies are available throughout your entire application. Let's dive into the core of Zenject, basic bindings. Bindings tell Zenject how to resolve dependencies, mapping a contract type to a result type. The contract type is the type being requested, such as an interface or a concrete class. The result type is the concrete type Zenject will provide. It defaults to contract type if to is not specified. The asScope method determines the instance reuse behavior for your binding. asTransient creates a new instance every time it's requested. asCached reuses the same instance, lazily generated on its first use. asSingle is similar to asCached, but ensures a unique instance within the container, throwing an exception if a binding for result type already exists. Zenject supports various injection types to suit different class structures. Constructor injection is recommended for non-mono behaviors, making dependencies explicit. Field injection uses the inject attribute on fields, occurring after the constructor. Property injection is similar, applying inject to properties. Method injection, recommended for mono behaviors, uses inject on a method called after other injection types. Let's look at a simple Hello World example. Here, we bind a string instance and a greeter class, ensuring greeter is instantiated at startup with non-lazy. To run this, create a new scene, add a scene context, and create a mono installer named test installer. Add test installer to the scene context installers list and paste the code. Installers group related bindings for reusability and come in different forms. Mono installer is for scene-specific bindings and can be attached to a game object. Installer tinstaller is for non-mono behavior installers, called from other installers. Scriptable object installer is ideal for game settings, as changes persist after stopping play mode. Now, let's explore advanced usage, tips, and potential pitfalls. 4 non-mono behavior lifecycle events. Use iTickable for update, iInitializable for start, and iDisposable for cleanup. Bind interfaces to and bind interfaces in self to are shortcuts to bind a class to all its implemented interfaces and optionally to itself. Configure settings using serializable classes or scriptable object installer to expose them in the Unity Inspector. Use factories with iFactory and from factory to dynamically create objects with injected dependencies. Zenject provides container.instantiate prefab or container.instantiate component for creating game objects. The Zenject binding component can automatically bind a game object's components to the container. From component and hierarchy can also be used to find existing components within the scene. Installers added to the project context prefab provide global bindings available across all scenes. The project context object is marked Don't Destroy on load, ensuring its persistence. Scene parenting allows specific scenes to inherit bindings from a parent scene, useful for modular setups. Lazy inject T delays the instantiation of a dependency until it's first accessed, Optimizing startup time. Prefer constructor or method injection to make dependencies explicit and prevent circular dependencies. Limit container.bind, rebind, unbind calls to installers and factories, adhering to the composition root principle. Use edit, Zenject, validate current scene to perform a dry run and catch missing dependencies at editor time. Control execution order for iTickable, iInitializable, and iDisposable calls using container bind execution order T priority. Enable reflection baking to move reflection costs from runtime to build time, reducing startup time. Use memory pools for frequently instantiated objects to reduce garbage collection and performance spikes. Avoid using Unity's native GameObject that instantiate for objects requiring Zenject injection. Use Zenject's factory methods instead. Dynamically created objects won't have initialize, tick, or dispose called automatically unless explicitly managed. Circular references via constructor injection can cause issues. Use lazy inject, field, or method injection as workarounds. On AOD platforms like IL2CPP, add inject to constructors to prevent stripping or modify link.xml. Use Unity's profiler with Zen_internal_profiling to get detailed Zenject performance breakdowns. Zenject provides a robust framework for dependency injection in Unity, leading to more maintainable, testable, and scalable code bases. Understanding its core concepts, binding mechanisms, and best practices is crucial for leveraging its full potential. Explore the official documentation and sample projects for deeper insights and continued learning.